Here we go. So we're just going to work through from number 1 to number 3. Okay. So the first thing I'm gonna be asking is not for the answer for number 1, but what does the question even mean? Okay. So what does the question mean? Oh, angry. What does question 1 even mean?
Um, the question is like underneath the table, right?
Yes, yes, yeah, yeah.
Um, so it's asking if like X is one, what's the answer, what the equation would be.
Good. So it's asking us what is the value of the function when x is 1? Um, Ali. I just need to remember the names. Okay, Eli. When we interpret this as we're figuring out what is the value of 1, what kind of would be the first thing you think we would do?
I'd write out like just kind of what f of x is.
What do you mean by that?
Well, what I would do, I guess, is if we're doing h of 1, I'd just find 1 for x, which would be 1.75, and I'd plug that into g.
Yeah, let's stop there. All right. So when we see h of 1, whenever we're plugging things in for a variable, like in this case x, it is always a handy thing to actually like write it out. Like if I'm trying to find h of 1, this means I'm doing g of f of 1. Right? We're plugging it in. Okay. That is true of any type of composition. Okay. Whether it's numerical like this or if we're like plugging in something algebraic. So then now we're going to ask like, what is the next step? Okay. So knowing that this is g of f of 1, what would be the next thing you would need to find? So I will say there is a pattern to the function here, but we don't need to find what the function actually is.
Look whenever X is 1. So you see the 1.75 and then plug that into G.
Okay. Yes. When I do want to, I do want to acknowledge that f is a function with a pattern that we could find, but when we're evaluating, you don't need to. Okay, you don't need to because it's saying we're finding f of 1. Well, f of 1 is 1.75. If you wrote g of 1.75 and stopped there, I would give you a point because you did the first step of the entire problem. Okay. All right. Now we're going to evaluate this. Allie, if your name comes up again, I'll just remove it. Ooh. All right, Caleb. So, what is going to be? So, what am I going to do now?
Oh, they're gonna plug 1.75 into the x of the g of x equation.
Good. What do we get?
7.5625.
7.5625.
Yeah.
Yes.
Do we need to like write all that out?
Here's what I'll say. If you just wrote the answer and you were right, yes, I would have given you the 2 points. But if like people just plugged 1 into G or something like that, and you just write the answer, I'm not. I think one of the things that is important about like any math class is, you know how last year when you were in geometry and you were like, dare say, you were writing a proof and you're working from line to line, you are communicating how would I go from one step to the next step to the next step to this next step? Because I want to understand what you're thinking through as you work through a poem. So in my mind, it is always to your advantage to show the necessary work to get to your answer. There are cases, um, uh, there are cases just because of being, in that AP math world, where it's like if you have like a calculator problem, you can't just write the answer, but you actually have to show the work. Now, it might be something as simple as this, but like just writing the answer is not enough. Yep. Yeah, there was one question on last year's exam that was a part of grading, and it showed, and like there was a phrase, um, it was like show. It was like essentially show work that leads to your answer or something like that. So like this isn't taking us that long. So in my mind, it's like it doesn't hurt to write down the work to see where we're going. Yep. Yep. Good question. Awesome. Great. So yep, 7.5625. Um, we could also do this if I gave you like an equation and maybe a graph, or maybe a graph and a table. I could have done that as well. The only type of function that I want to put in here was like a verbal description of a function. So, all right. Are there any questions about this first one? All right. Number 2. I do think number 2 was the hardest problem, I think. Um, because I think finding the graph of f of the absolute value of x is the trickiest of the 2. Okay. Now, the way that we are going to go about doing this is now we could find this function in the calculator, but what would be another way of writing this function? Yeah. Okay. So, so let's draw a table. Okay. So -5, 7, -4, 0, -3, -5, -2, -8, -1, -9. I did put a label there just so that like it was clear. 0, -8, 1, -5, 2, 0, and then 3, 7. Now, what does the first graph mean? Or the first equation?
Like the x values won't be negative.
And y values.
Yep. The y values would not be negative. So we're essentially taking all of these negative values and making them positive. Okay. I will put this in a different color. I'll put that in blue. That would be the same that would be the same. But then now, -3 would be +5. -2 would be +8. And -1 would be 9. And then it's symmetrical, which is nice. Okay. Okay. It's kind of that W-like shape. Okay. 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 So yeah, so that absolute value of f means we're taking all those y values and we're plugging them in, and we're making the negative values positive. Okay. What's interesting is that this, if we did a function like, if we did a composition like this, and it was, all the y values were positive, it'd just be the same graph. Okay. Table screen, let's do orange for this one. All right. So now I'm going to ask, what does the second graph mean?
Like once you plug it in, like the X values have to be positive.
Good. Good. So I think with what would be a good way to kind of track this? Yep. Good. So I would create a second table. Okay. Now the thing that is peculiar about this, is that you can't use all of the points. You essentially have to start at -3. Here's why. The reason you'd be more likely to start at -3 is because at -4, if you do the absolute value of 4, if you do the absolute value of -4, that becomes +4, right? Do we know the value of the graph at 4? Sorry. Yeah, do we know the value of the graph when x is 4? So that way we know that we would want to start at -3. So when we plug in the value of -3, it becomes +3, and it becomes it becomes 7, because the absolute value of -3 is 3. The value of 3 is 7. So -3 would be up here at 7. What if I then did -2? What if I did -2 then?
Would it be 0?
It's 0. So if we did absolute value of -2, that gives me +2. So that value is going to be at 0. Okay. What would the value be at -1? Go ahead, Allie.
Would it be -5?
Good. And then how about at 0? How about at 0? Let's get somebody else to go. Here, go ahead.
-8.
-8. Good. Now, before we do any of the other ones, Does anyone remember, even if you have to look back in those notes, does anybody remember, or that homework, does anyone remember the property of graphs when we did the absolute value of x? Does anyone, if you want to look in the homework, yeah.
I have a question.
Yeah.
Where did you get the -5 from the -1?
Yep. So when I did -1, the absolute value of -1 was +1. So I got the -5 from 1, -5.
Oh.
Yep. Good question.
The y-axis is an axis of symmetry.
Yes. So now that I know what these 4 points are, it reflects it on the other side. So the graph looks like that. So, and what is interesting? That is interesting. There is actually a small pattern. The change here is 3, then 5, then 7. That's not a pattern that we picked up, but it's good to, when you look at graphs, see what the different patterns are. All right. Yeah, so I do think that this one was the hardest because, particularly of that second piece of the absolute value of x. Okay. All right. Let's just pause here. Are there any other questions about number 2? And what's important to remember is that these characteristics are true of whether it's like quadratic or even like linear. Okay. Right, number 3. Number 3 was a little bit different than the homework, only because I gave you the graph to start with. Okay. That is the only reason that this one was different. Okay. Now, when we approached this problem before the quiz on Friday, I pointed out that there was a reason why I had 5 here and 5 here. Here's the other thing that's worth pointing out. When we had been doing that work with transformations, I remember having said in class about how when I think about how many points something is worth, essentially 1 point for every transformation. So that, I'll just say, that should be a clue that if the graph and tables were worth, say, 2 points, that there are 4 transformations. Okay? There are 4 transformations. Okay? I had some people who did write the y equals a f of b of x minus h plus k above the problem, so you could see the different pieces. Okay, because what's important to recognize here is that h is a piecewise function. You've got a semicircle and 2 linear functions. All right. Caleb. Oh. If I'm going to fill out this table right here, what do you think are going to be the 5 points that I take from my graph?
-4, -2, 0, 1, 4.
Yeah, so what is the value at -4?
-1.
And then at -2?
-3.
0?
-1.
And then what would be the last 2?
Then 2 and 0.
Okay, good. So these were the 5 points that you would transform to get the new graph. Okay. I did have people who did not identify each of these points. There are some that who did, there are some that did not. Okay. All right. Now, I said that there are 4 transformations. We're fortunate that there are 4. Well, there are 3 of you left. So let's see. Bang. No, we're just gonna work from left to right. What I just want to know, what does that negative represent? Which reflection? Is it gonna be over the x-axis or the y-axis? It is. Good. It is the x-axis reflection. Because what this negative in front of the h represents is that all of those y values are going to become negative, or those negative values are going to become positive. We're reflecting it over the x-axis. And what does that 2 represent? Good. A factor of what? What's important to remember is that when we deal with dilations, we're dealing with positive values. We have already dealt with that negative sign by identifying the x-axis reflection. Now, if people put on the quiz, if people put x-axis reflection in a vertical dilation by a factor or a vertical dilation by or like -2, I did not count that off. Because you knew that there was something separate there, right? You knew that -2, there were 2 transformations, okay? Technically speaking, dilations are positive values, okay? You can't tell. All right, Eli.
Cool.
What is that x -1? What does that represent?
Is it a horizontal translation of form?
Good. Awesome. So remember, with the horizontal transformations, whether it's a dilation or a translation, it is kind of what we write down is kind of the opposite of what we see inside the parentheses. So this is a horizontal translation of 1 unit. So it's moving in the positive direction. Which then leaves with me what is that -2 then? What is that -2?
A vertical translation.
Yes. Of what?
-2.
Good. Awesome. Okay. All right. Now, if people had written down the transformations correctly, 4 points. Okay. Because I think that is where the weight of this problem is. It's being able to identify each of the different transformations. Okay. All right. Now, everybody has been spun. The real question is, do we restart? Yeah, okay. Wait, hold on. Why does it look like there's more on here than there actually is?
You looked on it twice.
Oh. Oh. Mr. Shoemaker, which transformations am I going to apply to my x value?
Would it be the -2 or the -1?
Yes. That horizontal translation of 1 is going to affect those x values. Okay? Because this is saying with a horizontal translation of 1, all of these x values are going to be moved in the positive direction. -4, -3, -2 to -1, 0 to 1, 1 to 2, 4 to 5. Okay? If you had gone these right, I'd have given you another point because you applied correctly the horizontal translation. Which means these other three, the reflection, the dilation, and translation, are all going to be applied to the y values. Okay? Now, this is where, when we did the notes, we were writing down each of the different calculations. Okay? So here's how we're going to do that. I want you to see what's happening with these. Okay? So we're doing -2 because of that vertical dilation and x-axis reflection. -2 times -1 minus 2. That -2 is then the vertical transition. We have a minute and a half. Here we go. -2 times -1 is 2. 2 minus 2 is 0. Which means I'm going to have a point at 1, 0. Okay, because it's -1 there as well. Then -2 times -3 minus 2, that's 6 minus 2, which is 4. -2 times 2 minus 2 is -6 because it's -4 minus 2. And then -2 times 0 minus 2 is -2. Now, I plot the points. -3, 0. -1, 4. Sorry, that like on the PDF on the screen, it doesn't show up really well. Then 1, 0. Okay, so that's kind of my stretched and reflected semicircle. Okay. Right, because it stretches it and then it flips it. 2, -6. 2, -6, which is going to be all the way down here. Okay. And then 5, -2. 5, -2. Don't leave quite yet, please. Bars quiz will completely replace your quiz grade. Okay. Between today and tomorrow, here's what you should do. Compare the answer key that you all just wrote down with the mistakes that you made in your quiz. Okay. Up here. If you want to come in during career time, I will be here. Then. And then. So look at the quiz that you just got back with the answer key. Okay. I'll be here during career time. You can just come in if you want to be here. Okay. Okay. And it's still too cold. These are the y values. So it's because with -4, moving right 1 becomes -3. And then when I take that -1, I reflect it and stretch it and then move it down 2, it becomes 0. Yep. Yep. Right.
Mr. Hall.
Yeah.
Where do you get the -1, -3 to 0?
They're the y values. Yep. Yep. So I'm applying each of the transformations to the y values to get the new ones.
I also have a question.
Yeah.
For the equation up top,
Mhm.
you saw that it was an x question.
Yes.
How do you see if it's like a y axis?
It'd be negative on the inside.
Okay.
Yep.
Okay.
Yep. Which is
Okay. Thank you.
That's a transformation that like I rarely see like moving forward. So like, I don't.
I thought the negative was overall. And you could argue that.